Hi, so I thought I would do a walkthrough of the code in the tutorial because some people have been struggling with so many files and I didn't appreciate how hard that would be. So we'll do a quick walkthrough and we'll see if I can help you understand the parts of the code and what's going on. So if you start with your Visual Studio Code up and you get something like this, I would go to File, Open Folder, and here I need to go and find where that folder is. For me, it's on my D drive under Git. Oh, you can't see this. Interesting. So it's under Git, and then you can't see my drive, but because I'm not sharing my screen, I'm just sharing the window. But I go down to comp261 and then down to 2022 code tutorials tut1, and when I see the .vs code folder, so when you're searching for your file, once you see .vs code, select the folder that you're now looking at and go select folder. Right, so that brings me to my code on the screen. So just to check that you're in the right place, if you click on the Explorer window, right, so you can see this Explorer window up here, so click on that one, and scroll to the top of the bar there, and then see that you can see VS Code, right? So if you can see VS Code and you can see the launcher in the setting, then so long as you can see VS Code, you're in the right level. If you're using Maven, you'll just see settings. If you're using the raw mode, then you'll see launch and settings. Now, I have my data files, which is an edge file and a node file. And so if we sit down, don't worry, the bin is where it puts class files. So data is, I've got two files in here. I have a CSV file, and this has an edge ID, which is just a sequential number, a from, a to, and a wait. So this is an index number, right? So this is saying from node 0 to node 1 in the index, there's a weight of 5, right? So this is an edge graph. The nodes have a node ID, which is their sequence in this list, a node name, and I've just used A to J because that's what we have in the tut, and I've given them a location number, which is an integer X and Y, right? Just to place them around. Now, you see, I've got old VS Code because I was doing other things. You shouldn't have that one, but you should have a source file here that has comp261 tut, and it will have comp261 and then something here. So if we make that a little bigger, you see what we call tut1, so I'll make that more again. And within that, that's where we have all of these files. Now that lot are a big number of files, right? So I recognize that that's going to be a challenge. So what we're going to look at having to do is, if we go into these, we've got edges, graphs, graph controller, main, map viewer, node, parser, strings, lots and lots of files. Okay, so how do we break these up? Well, the main one, that is important, is the package, right? So it's this one here that is the main start Java file, which is what you're kind of used to as being where your main function is, right? Main method, right? So static void main string args and do something. And you see in Visual Studio Code, we've got this run and debug. So this is the main entry point, as we call it, for your program. So that is main.java. Okay. Now, technically, up here in launch, that's what this main class tells us where that main is. Okay, so this actually tells us where that main is, so that Visual Studio Code knows where to look. Okay, so we go back down here. This is the main. So if we just go quickly through the main, what do we have in the main? Well, we have the package, and it's asking me a question about that. Okay, I'll get back to that. I was playing with this to make this a Maven tutorial, so that's why the code is slightly different. So Java I/O. So these imports just bring in particular parts of the Java environment. Right, so those are quite useful, but they are important different blocks of the Java system. So we have a main. The main class extends application. Now we're using a JavaFx, and so JavaFx has a class which is an application class, and so that's an abstract class which you then have to extend to build the actual class you need. I've created a public static graph. So I've said, okay, one of the variables in this main class is going to be the graph that we're going to use, right? So that's the core data structure that I'm going to use, and we could have other data structures in here, but this is just the one sort of global data structure I'm going to use. I then have the start function. Now the start function, when it calls launch, when this called launch with args, that goes and tells Visual Studio, it goes and tells JavaFX to run the code, to start, to launch the code. And so it launches by looking for the application, right? And that's in main, right? So that's where it kind of goes and finds the main and launches that application, right? This main class where the launch, right? So this launch, that's where it goes and finds it. Okay, so we go back to main. So that's how we get to this point, right? So, and the first thing it does is call start. Okay, so in start, we have the first section is the language locale. So here we're loading some strings. Now where are these coming from? They're coming from comp261 tut strings, and if we have a look down here, we have strings and we have English strings, and so the key title becomes the string graph viewer. The key load becomes load, quit becomes quit, search becomes search, node becomes node. Okay, so those are the English language ones, and those are an initial multi version. Okay, so it's going to load the New Zealand English version. We then have loading the Fxml file, right? And so you don't have to write this, this is included in the tutorial. So we have this load here, loads up the map view XML with the language bundle that we just loaded. And if we have a look over here, we've got this, and it's a big nasty file that has lots of XML in it. The main things to know about this file is that in here you'll see these FX IDs, right? So you've got a bunch of buttons and some text and labels. The buttons have IDs, and if we scroll over to the right, they have text. And the text, in this case, has a percent in front of it to say, oh, instead of using the text, use the language translation for the word load. Okay, so this describes the user interface. Right, and so we can go into that later, but it's got a VBox and children and a grid view layout, and at the bottom here it has the map canvas. Okay, with a height. I probably want to make that height about 700, not about 550, but we'll talk about that later. So we have back to the main. So now I've loaded the languages in. I've loaded the visual GUI in. I then have to do some setting of details, so I can set the primary stage is actually what was passed in to start, so that's something that it already knows. So this is your application starting up. So the primary stage gets set to the title of get from the bundle, get the word whatever was associated with the word title, put that in here. So that could just be a string, but it is a lookup. And then we set the scene size, so 800 by 600. We could make that 800 by 700 to make it a bit longer. That would be useful. We show the stage, and then we do a set on close request system exit. This is just when your when you hit the close button, what should it do? So if you've got memory you want to clean up or something you want to save before you quit, you put it in here to save just before you quit, because that's what the person's asked you to do. Right? So that's the quit file. Then we go into the more actual code. Now, I was originally not doing these loading of files before going into the code itself, but it was really annoying to have to go and load files all the time. So I've, instead of using the load file button, I pre-put in some loading. So here we go, file, node file equals new data slash node.cbs, and that's that data file we found in there, and it's in the directory relative path to now to the code, to the root directory here, to data node cbs. Right, CSV. So that will grab the node CSV. This will grab the edge CSV. Checks that they both exist. Otherwise, it just says, "Hey, file's not found." As system out. And if it does find the files, right, and it will continue. So you can then see, because it will continue, you can go and load the files. If it didn't find either of these two, you could go and load them yourself. But the normal situation should be that the graph finds it and then it creates the graph. So graph, new graph with the node file and the edge file. And this is, and I've got an old, it said, yes, we had to cast it to graph controller. This bit was the way that the main program, this one, can go and see the controller. Okay, we haven't talked about what a controller is. What's a controller? Why have I got a main, but I don't know what's going on yet? Well, in the model view controller, what we have is we have a model, as I said, a model view and a controller. So if I bring up this, so if we imagine we've got kind of the up here, and we've got a thing there and a thing there, and so this is the controller. Ooh, that's not working particularly well. I will just try that again later. We have a model view and a controller. The graph controller is our controller. So when it says get controller, it says, hey, what controller are you referring to? And this is going to be a draw graph, because I'm telling the controller, hey controller, go and draw the thing that you just loaded here. This graph, like draw a graph. The controller knows about the main and knows about the graph and its structure, and it will go and then draw that. I could have passed the graph in here and be passing the graph around rather than having it as a global, but you know, I'm starting with having things global. We can move to having them passed around in later tutorials. Okay, so that's what the main file does. The next most important file is actually the graph controller, and this is kind of the biggie, right? Because now I could have broken this up into lots of helper files, but I kept it as kind of one big file so that it's kind of easier to follow through and you don't have to be going back and forth between various different files. Okay, so the controller is what allows the interface, the view, to talk to the data. So in here, again, we are part of the same package. We import now a large number of Java features and all the Java events. And we start with the class controller, graph controller. Now the graph controller, the first block of text here is loading all the interactive components out of that Fxml, out of the GUI. So the Fxml is the description of where the buttons should be and where these fields should be. Here I go through and I allow Java to know the names of those elements, right? So I've associated these variables with the Fxml file, right? That's down there, right? So these are these Fx IDs, and graph controller, they're these. Now, in the map view, way over here, and it's hard to see. So in this first in this first view here, a VBox, way over the right hand side, you'll see, oh, it went down, it scrolled down, that's why I went too far. Fx controller is the Qt graph controller. This is the bit that tells this Fxml who will be connecting to it, right? And it's going to be this class graph controller. So these buttons are now associated. So if we then step through, the next block is those that are used to map the nodes, or these are used to map the nodes from the location. Now, in the simple version, I've got a relatively small scale, so I multiply it by 2.5. So my model XYs become twice as large in here. Now, why should that be? Well, if we go and have a look at the nodes, these are positions that go from about 20, right, on the X to 140, and from about 20 on the Y to about 110, right? So they range about 100 to 120 is the scale, but I have in my graph these set up, this particular graph set up to be, if we have a look down the bottom here, we have right down the bottom, we have the map canvas. Its height is 540 and the width is 800. So it's kind of, well, that's 800. So I've got something that's only 200, like 100, and I'm trying to put it in something at 800. I need to scale it up a bit. I could have scaled it up so it takes the whole size, but I just scaled it up a bit. Okay, so that's what, if we go back to graph controller, that's what that scale is doing. It's scaling up the model X and Y onto a screen X and Y. I also make a point of the origin in the graph, right? Because that graph goes from about -20, or it goes from about 20 to 140, and goes from about 20 to 100. So about 100. So putting a point at 180 is near the middle. So I'm basically shifting the pivot point to near the center of that object. Node size. This is the drawing size of the node. All right, so that should be drawing size. Would make that simpler. As 10. Move distance moves you by a certain amount, and that move distance is currently set at 10, and that's, so this is a scaling to sort of how big you want those individual jumps to be, and the zoom factor is when you zoom in and out how big the scaling is to be. Okay, so those are both going to be used later. I have an array list of highlighted nodes. So I'm creating here, and this is looking into the future. I'm going to use some highlighted nodes, and it's going to be an array list. And I created it up here because I was thinking of, well, I'm going to need this list, and I'm unfortunately an old C-style programmer, so sometimes I put things in the beginning when they're used later on. There are some people who much prefer everything just to be declared locally. So, but that highlight node we'll be using later. So let's have a look. What have we got here? We have a map model to screen scale and overlay. Right. So what we do here is we take a model XY. So we have the model XY. So we take the model, right, which is what we've been passed in, the model X's. We get its X out. We take the model to screen of that value, and we put it into a point 2D. So we create a new point that we return from this function. So how does that do that? Well, it uses this model to screen X, and if we go and have a look at model screen X, it takes the X, it subtracts it from the origin. So it says, well, what's the center of your graph area? How far away from that center am I? And it multiplies that by the pixel scaling to say, okay, well, that's how far away you were from the center of the model. Multiply it by the pixel scaling, and then move that basically to the center of my graphing area, right? So that's the map canvas width and height. And again, I do the same with the get screen to model. I can give it a point, or I can get the X and Y, the X and Y separately, or the point. And these do the reverse of that. Okay. So as we come down here, the initialize currently doesn't do anything, but you could do some more setup things here if you wanted to. I didn't in this case. Right, okay, so those are utility functions at the top there. We're now into the what happens when I click buttons on my screen. Now, if we go back to the map view, one of the things, if you have a look at this, you'll see that there are on actions. Right, so each of these buttons has an on action associated with it, and it gives me a name, hash handle load and hash handle quit and hash handle zoom in. If we go and have a look at the graph controller, which it said, hey, that you're the controller for me, that's what the names of these functions are. Right, so, and it's on action, and so it gets past an action event. Right, so that's what the Fxml on action coming to here, which is the action loader. So this is the handle load. So what this code does is it grabs the map canvas and says, hey, what stage am I on? Well, this is the stage I'm on. I'm on the map canvas, gets the scene it's in, and gets the window that I'm in. Right, so it now knows where we're talking about. And I just do a debug print line statement. You don't have to do that. It's just useful sometimes to know. And then I go through a file chooser. So if you press the load button, it does a file chooser. I set a default path, and I said, well, if you're not allowed to read the default path, then set it to a C drive. That may or may not work. And then it does load, and it does the file set title to open node file. So in the top of the file view, you'll see that. And then it does a choose the file, right? So standard file loading up to that point. The interesting thing, and if we do this, I could then say create the graph from the files. Okay, so this is going to do graph equals new graph, and it's going to create a new graph using the node file and the edge file, and then it's going to tell the graph to draw. And the event consume means that if you've got layered buttons, the top button will consume that event, so you don't click the buttons below it or behind it. Sometimes if your modal dialog pop up and you have an OK button, if you click there, you don't want the click to propagate down to the things behind it, right? So that's what that consume events does. Okay. So the handle quit consumes events and then exits, and then we handle zoom in. We have a zoom in function, zoom factor, and this divide by scale was something I added because the scale was so large in the assignment. I thought I'll show you how to do it here by scaling down the move distance according to the scale that you're viewing. So if you make the layout map really, you zoom in really long way, you don't move and everything just throws off the screen, right? So you need that movement to be scaled by the level you're scaled in, right? So that's why it's movement divided by scale. Okay, so handle up and down, left and right. Okay, that's hopefully good so far. So we have handle, those are good for left and right. Hopefully you can go and have a look at those yourself. Then we get down to handle search. Now this is an interesting kind of slightly similar to what you're going to be doing in the assignment, is that you have a handle search, and I'm going to do a lookup. The string search equals the search text dot get string text. Search text. Search text is actually one of those lookups that I had when I associated all the buttons up here. Right, all of these buttons got associated up here, and the search text is one of those. Right, so that's where that is defined in the XML file. So if we get back to the search, so we're now in the search. This gets that text. I clear all my highlighted nodes. I then go I do a for loop, and I go through saying, look at for each node in the graph, get node list. Now get node list just returns me the nodes in the graph, right? Because the nodes in the graph, we have a look at now this is where we might need to look at the graph. Go and have a look at the graph. The graph is a class. It has an array of nodes and an array of lists, and I also made an adjacency matrix just so I could show how that works. Okay. Now the graph has, when you build it, it adds, if you give it the two lists, it'll just assign those lists. If you give it two files, it can parse those files and then build the list, and it can get the node list, and it can get the edge list, and it can build an adjacency matrix, and it can get an adjacency matrix, right? So that's the data structure graph. All that is. Okay, so relatively simple. If we scroll down, we see that we're saying get the node list, search through the length, through the search string, right? Look at see if the search string is greater than 0, and the node contains the search string, then add that node to the highlight nodes and display that in the node to string. Okay, so this is going to display it in. So this node display, where's that? Well, that node display again is in the Fxml, because we have a look up here, we can see we have node display and search text. Okay, so those two are coming out of the XML file. Now, so that's what the search string does. It then goes through, highlights those, and then redraws the graph. So draw graph is going to be somewhere. Where's draw graph? It's down the bottom of this file. We handle a click by doing a click through and screen point. Right, we work out the point. We get the event X and Y, so we create the screen point. We then move the screen point into our model X and Y. So this should be probably model X and model Y. And we highlight the closest node to that X and Y. So highlight closest node is this code. And it says, give me an X and a Y in model space. It will set the minimum distance to double max value, and then step through all the nodes, setting the node distance, finding the minimum, and then, if it's less than maximum node value the first time around, it will set that minimum distance and say which is the closest node, and then it just keeps searching through every node until it finds the nearest one. If it couldn't find any node at all, it does nothing. If it could find a node, it clears the highlighted list, adds that node to the highlighted list, and then also sets the text in node display to the string, and then redraws the graph. Okay, so it's a redraw of the entire graph. So I'm not just changing that, I'm not just overdrawing that individual node, which I could do. I'm just doing a refresh of the graph. That's a bit slow, but machines are pretty good. The last bit of the graph controller is where we do the actual drawing. Right, this is the interesting bit. So here I've got a draw circle, which in the map graph, right, the map canvas, get graphics context 2D, is called fill oval. You give it, and I'm offsetting the X half the radius and Y half the radius, so the start point's up in the top corner here, and then I draw it the radius size, right? So actually that should be diameter, not radius, because yeah. So I could, and actually I probably should have made those minus radius and this times 2, because that would then actually make the radius the 10 and the diameter 20, and you offset by the radius. So sorry, that was me just going, oh yeah, no, I have to do half of the size. But if I'm calling this radius rather than diameter, this should be minus the radius, and this should be 2 times radius to make the diameter, which is the width, right? The width is twice the radius. Draw a line, give it XYZ, and it does a stroke line, right? So I could have just used that directly because I haven't got any other context going on, but I just sort of make draw a circle and draw a line consistent. You could change these if you wanted to. The draw graph steps through, grabs the graphics controller, clears it, so it cleans it out, right? So it erases the graph according to the width and height. It then grabs the node list, and then for each item, right, so the node list for each node in the node list, you go through and you set the size it's going to draw to node size. You then do, if it's highlighted, right, if the highlight nodes contain that node, then draw it red and double its size. Otherwise, draw it blue. And then, we're going to get a screen point from a model point. So a node has a model point, we turn it into a screen point, and the circle gets the screen point X, screen point Y, and the size. And again here, draw edges. We go through our edge list, we go set it to black, we find the start, the end in X and Y, and we draw a line from the start XY to the end XY. Now, this whole bit here, this node list, I say, okay, from the node list, I want you to get the ID that comes from the get from, right? So the edge, because that's the thing we're stepping through, has a from, so I get the from that. That allows me to work out which node I'm referring to, which is what this is now, and then I get the X from that node, and then I wrap that to go from the model to the screen. Okay. And this last bit is just the adjacency matrix. So I'm going to stop there because I've got to rush off and go and get my son from school. Hopefully that's a good start to the introduction to what this code is doing. You can go and have a look at the edges. That's a relatively simple file. It's just looking at the edges, just stores an edge. The node file just stores the node. It has a whole bunch of functions that do very simple things. But the main bit is that a node has an X and a Y and a name and an ID. The parser file is what reads those CSV files. You can hopefully go and have a look and see how that works. And then we just have the language files. Okay, great. Hopefully that's been interesting and a quick walkthrough. I will create more as people ask me to.